So, dear students, today we will see the representation of stack and queue using linked list and linked queue. In last lecture, we have seen the linked list, its operations, as well as double linked list and its operation. And today we will see how the representation of stack and queue is used by the linked list. The question can be asked as write the procedure for push and pop from stack using linked list, or show the stack using linked list how it is represented. So in the previous unit we also have done stack using array. The main advantages of using linked list over arrays is that it is possible to implement stack that can shrink or grow as much as needed. As we have seen that array is of fixed size, so here if we will use now stack, that is nothing but we will represent stack using linked list, then it can shrink, means it can reduce or it can expand unlimitedly. So in using array we have the restriction of maximum capacity which can lead to the stack overflow, but here we can allocate the new node in a dynamic way, so overflow is not possible. Now as we are dealing with stack is nothing but last in first out, where the last element inserted in the stack will be the first element which will be taken out. And for insertion and deletion, only one end is there, which is called as stop. For insertion and deletion, two operations are used in stack, that is push and pop. Push is used for inserting the element and pop is used for deleting or removing the element. So the stack operations are push, pop and display. By push we can insert the element into linked list by the top node, and by using pop we can remove the element from the top node. Display is nothing but printing the all elements of stack. Now when we want to represent stack using linked list concept, stack is nothing but last in first out, and we are going to represent it by single linked list. So single linked list is nothing but a collection of nodes where the nodes contains the data and the pointer to the next element. So when we want to display the linked list by using the stack, we have already said that linked list is nothing but collection of nodes where each node is having data and pointer to the next location. So when the first node is there in the linked list, it is called as head because it is the starting node. And when the last node is there in the linked list, the pointer is at the null direction because it is not pointing to any next node. So take this particular example over here. Now we are having stack and we want to push 11, 22 and 33. Now 11 is put first, so it is at this location. Then 22 is put, so it is at next location. And then 33 is put, which is the last element, and it is present at the top because this is the last element which is present at the first location. So we can see that initially the stack having three elements, that is 11, 22 and 33 with the address of 4800. Now in this example we want to push 44, means we want to add this particular number 44. So in last step the top was to 33, and now as we are inserting 44, the top will be moved to 44. So the element that is inserted 44 is the last element which is present at the first position in our stack. So as we can see, we are representing it with the linked list concept because your each and every node is allocated with the address, that is nothing but the pointer. So now we want to pop the elements, that means we want to remove all the elements, look over here, which were present. So initially we have pop 44, so that is removed. Then we have pop 33, so that is removed. We have pop 22, so that is removed. and only 11 number is present, so that location of top is over here and the 11 is your last node, that's why it is representing to the null pointer. So this is the way by using which the stack is used, or the representation of linked list is done by the representation of stack is done by the linked list. So for that we have used push, pop and display function. Now the same thing is applicable to queue. Now we know that queue is first in first out, because the element which is inserted first is the element that will be removed last. From front we can delete the element and from rear we can insert the element. So queue is nothing but the data structure having two uh, nodes from which we can insert and delete the particular numbers. Now when we want to represent the queue by the linked list, so here is the example. Front is used for deleting the element and rear is used for inserting the element. Front and rear can be at any side of our particular queue. So here we can see we are having this particular queue 10, 15, 22 and 50. These are nothing but the various data elements present, and 1004, 1008, 12, that are nothing but the various pointers which are pointing to the next memory location. Now this is particular 50 is the location, that is, and the null pointer is given here because null is representing there, it is not having any next pointer. So by using queue we can represent the linked list. The queue representation has been done in such a way that the normal queue is shown and the data and the memory location, that is nothing but pointer to the next element, has been shown. Now if we want to insert the element, delete the element in queue, we can insert and delete the element from front and rear. So this is nothing but how the queue is represented by using the linked list. So today we have seen stack and queue, using stack and queue representation